a question that often comes after a bit of thinking and hanging around at the campfire. Things that 6-year-old children will ask you and you think, I've got no idea. Luckily, the geographers, they're the people who look at the earth, the air, the water, the land, finally have enough information to give us an answer. So what we've got is a situation where the earth is spinning once every 24 hours or so, and then either God, the devil, or the aliens come along with their superpowers and they go, stop. Let's just do a gentle stop over a period of a day so that at the equator, people don't go flying off at 1,600 kilometres per hour.
Is that what could happen if it stops suddenly?
Yeah. So at the equator, it's moving at around 1,600 kilometres per hour. At Sydney-ish, which is about 1/3 of the way from the equator to the pole, it's moving at 1/3 of that. And then at the pole, it's moving very slowly. So what would happen firstly is that you would have day on one side of the planet, which would just keep on going and going and going, and then night on the other side of the planet, which would keep on going. So one side would get blisteringly hot, the other side would get freezingly cold. There would be a twilight zone where life would be inhabitable, would be able to survive, but this twilight zone would slowly sweep around the Earth once every calendar year as the Earth, non-rotating, were to orbit around the Sun. So let's just forget that, because what would happen would be that the oceans would freeze on one side and evaporate on the other side. Yeah. Wow. So, but let's just pretend...
Would that make the Earth then lopsided?
Yeah, so it's the spinning of the Earth that keeps it tilted at about 23.5 degrees, and it has been claimed that without the spin that it would just sort of go any which way. So let's just ignore those issues as well, which are rather deep issues, and then just go to the straight centrifugal spin. Now, you've heard of the thing of hurling the billy, where you get the billy and you spin it around.
It's a good campfire tradition, even if I haven't done it myself.
Yeah, and the water stays on the outside, the top end of the billy, even though the billy is above you. And it's held there by the so-called centrifugal force. Little diversion here. The physicists are having a heart attack. They are shouting at the TV saying, Carl, there's no such thing as centrifugal force, it's centripetal force. So let's just call it the outward force, okay, to make them happy. So you've got this outward force. Okay, let's pick one situation where the Earth is not spinning at all and you've got oceans and stuff. And now let's just spin it up so that the equator is going at 1,600 kilometres per hour. Over time, two things happen. Number one, over billions of years, the Earth goes from circular to bloated in the middle. 21.4 kilometres more bloated across the equator than up-down.
Right.
But that's taken billions of years.
So is that land and water?
No, just land.
Together?
Just naked land.
Right.
So the land you think of as being fairly inflexible, but given enough time, it will sort of bulge out slowly. Right. The second thing is that the water also bulges, and it bulges by a distance of 8 kilometres. So if you compare two scenarios, the Earth as it is today, suppose you just suddenly stop at clunk, well, the water would then go down from that 8 kilometre high bulge. So it would leave the equator and start heading towards the North and South poles. Ignoring the freezing cold on one side and the searing heat on the other, you could walk around the Earth and stay on dry land all the way around the Earth at the equator. So you've got this, there would be this mega continent formed, a band with a minimum height of about 2 kilometres. Now the water's got to go somewhere, and it's going to go to the north and the south. So suddenly you've got two oceans formed. You've got the Northern Ocean and the Southern Ocean. It's quite separate, never any mixing. So that's what you'd end up with. If, to answer the question of the 6-year-old, what would happen if the Earth were to suddenly stop spinning?
What would it do for things? Would it in fact impact on such things as magnetic fields?
Oh, that's a deep one.
Weather patterns?
Yeah, just go straight to the magnetic field one, right? So what we've got is the Earth like a ball, kind of, and it's spinning once every 24 hours, or 365 times a year. Okay, you go down from the surface where you've got solid rock for 6 to 60 kilometres, then you've got sort of molten, liquidy, gluey type molten rock, then you've got liquid iron, and then finally you've got a ball of solid iron. The ball of solid iron rotates one every 366 days. what is that all about? Why is it one day different? What's going on there? And so it is thought that this rotation causes the magnetic fields. Notice the thought, we're not 100% sure. We're pretty sure, but not 100% sure. There's still things that we humans don't understand about our universe or even our own planet. And so we're thinking without the rotation of the Earth, without the rotation of there, that the magnetic field would stop, that the radiation from space would just come straight through, and there'd be massive mutations in life, but the life could exist only in that narrow twilight zone around the planet, and would have to then travel. You'd have to do a complete orbit of the Earth, a complete loop around the Earth every year, and you could have... By the way, the Northern Ocean would begin and run all the way to the pole at about the boundary of Canada and the USA. The Southern Ocean, sort of Canberra. South of Canberra, wet, everything north, dry. And so you'd have to be at Canberra, and then you'd have to travel around the Earth once every year chasing this twilight zone.
My goodness, it is rather a perplexing thought, Dr. Karl. So tell me this, just how likely is this scenario?
A scientist will never say zero, but it's so close to zero as to be indistinguishable from zero. It's possible, but highly unlikely that God, the devil, or aliens with superpowers will come and make this happen.
Well, it has been a very, very interesting endeavour in theory. Let's hope not in practice. Dr. Karl, thank you very much.
Thank you, Dr. Miriam.